Hi, it's Mystery Dumpster Teardown time. We've got an interesting bit of specialised industry test equipment here. Well, test equipment, I don't know. Is it? Leave it in the comments down below. But anyway, what is this thing? We've got a membrane keypad here with some 7-segment LED displays. We've got channels and data and memory and print and message print, cursor keys, list, feed, all sorts of stuff. Wow, it's a big beast. Look at this. It is, ta-da! You might think that this is a chart recorder, and it kind of is, but it's a hybrid recorder, whatever the heck that means. It's from a company called San EI. Apparently it's an NEC, a subsidiary of NEC or something like that. I cannot find any information on this thing at all. I can barely find information on the company. And obviously you can see inside there that there's some sort of graph plotting paper or something like that. We've got what looks like a big LCD up here. I don't know if it's dot matrix or character, and the thing weighs a ton, by the way, and it's absolutely huge. And ta-da, there we go. We can open the door. We can access our paper feed system, and you might think, oh, you've seen these, recording like seismic activity and stuff like that. Well, there with the needle going back and forth for an ECG, old school ECG machine. Well, this one is actually a dot matrix ribbon printer. So I'm not sure if you can see right up in there. I'm not sure how to get can I get the cartridge out? There you go. It's a color dot matrix print head like that, and it can, like I've seen like images of what sort of stuff that this thing can actually produce, and it can produce like really fancy graphs and text and basically big reports and things like that. Anyway, it's obviously designed for like kind of general use, I believe. I'd be surprised if the inputs aren't like, multiple inputs like 0 to 1 volts and things like that, because you can, of course, select the channel up here, and it's got the, I don't know what the data thing is, but, it must have, there it is, memory, ready, full. It's obviously got some memory, and then you can print it out. So it looks like it may not print in real time. It may, that's why, hence maybe why it's called a hybrid recorder. It'll like record the data digitally and then you can print it out later. I don't know. Anyway, the great thing about these hard copy printouts is that, well, a nuke could go off, electromagnetic pulse, we can get a huge solar storm, wipes out all the electronics on the planet, and well, you still got your hard copy printout. Beauty. On the back here, we'll have a look under the cover in a minute, but there you go, hybrid recorder. RD3130. I'd love to know how many of these. Anyway, it's made in Japan, and Yokogawa actually make similar kind of things. It's had a bit of a bang. That's probably where they threw it into the dumpster. But yeah, I'd be surprised if this doesn't fully work. It probably just threw it out because, well, they don't need a chart recorder anymore. So let's whip that off. Oh, wow. I didn't expect that many inputs. Wow, that's incredible. Unbelievable. That's like 30 inputs. Wow, all screw terminals. Look at that. What the heck is this thing for? And like, as I said, I assume they're like, maybe it'll have like, maybe a selection of input levels if you're lucky, but it might be like, just like 0 to 1 volt input perhaps, or 0 to 10 volts or something. Then you've got all the grommets down there to get all your wiring out. Oh, it's just beautiful old school. They're huge terminals though. Why they need such big terminals? Is it designed for power stuff? I don't know. And curiously, each input looks like it's 3 terminals, A with 2 Bs. So there's a plus minus, and then there's another one. What's the deal? Anyway, there you go, 100 volts AC DC max there, and 300 volts to mains earth. And it looks like that extra B terminal is just like maybe they're connected together. Have to buzz it out. I'm actually measuring nothing between the B and B negative terminal, and I'm measuring like it's open on the positive and negative input. So it's not like a low impedance input. It's like practically open. Now, I know you want to see inside this thing, but I'm really curious to know if it works, and you might be wondering, where's the power button? Well, this is the first time I think I've ever seen a power button inside a product. It's buried up under there. Power on off and LCD adjust. Okay, so let's push it. Whoa, there we go. It's just homing or something. Yeah, it's just doing its power on test. And, oh, yep, clock. Yeah, the clock's gone ski. Error. 3 degrees C. It measures the temperature, does it? Oh, that LCD's not great. This looks terrible on my camcorder screen. It's not much better in real life. Anyway, version 1.04. Clock, 1st of the 1st, 18. By the way, this thing actually fairly recently used. Last calibrated 2015 and due on 2017, so it's been used fairly recently. Set data backup. Oh, it's actually automatic. I thought I heard relays. Look, it's automatically cycling through the channels. So that's why we're measuring nothing, because it's obviously got relay inputs. There we go. It's actually testing all of the channels. It's just taking time to power up. So we've got an error on the day minute, but yeah, okay. Push monitor. LCD, real-time bar graph. Wow. There you go. Burnout. This LCD is terrible. It's terrible, Muriel. Okay, I just pressed the record button and it's doing something. The record LED's on. And is it printing something? I can't really hear any, dot matrix print head going. But it's certainly moving the head. It's gone back to channel 1. It just reset itself. Yeah, it's just measuring like, wow. It's set like one channel every couple of seconds or something. Yeah, without a manual for this thing, geez, could take you a while to figure out what the heck's going on. I was beginning to suspect that this was some sort of like a temperature logger, because like having like degrees C and millivolts over here, I figure it was something like that. So I select the input. Sorry if you can't, hope this turns out, geez. But anyway, cold junction unit, degrees C. So it's got cold junction temperature compensation, the range -200 to 1370 degrees C, scale 0 to 200 degrees C. So it looks like this is a 30 channel temperature chart recorder. Wow. And it looks like the previous operator had some fun with some rubber feet here, obviously taking rubber feet off a product under test, or or some system or something like that, and just stuck them on the top. I guess they were bored just waiting for the output. Sorry, there we go. I'll just overexpose that. That's better. And here we go. Here's the different type of temperature sensors, and let me increment and decrement button. We've got K-type thermocouple, a WRE05. I don't know my temperature probes that well, but different types. B, S, R, T, J, E, and K-type. You're most familiar, your multimeter comes with like a K-type thermocouple, but there are different types. They have a different mixture of metals in them so that they have different temperature responses, different temperature ranges, and all sorts of stuff, and hence a different junction temperature, and this is why you've got to compensate for that. Oh yeah, there we go. You can see the temperature range change with that one, 2300 degrees C. So this is, this is designed for 250 to 400, okay, for a T-type. There you go. So this is really designed for serious business, 0 to 2300 degrees C. Wow, this is designed for like real specialized, like, physics experiments and, all sorts of other, industrial processes that need these massive temperature ranges and accurate multi-channel recording. You might be testing like a new jet engine or something like that, and you've got to put like 30 thermocouples in the thing at all different points to measure all the different temperatures at, 1000 degrees and stuff like that, and to make sure your titanium parts and other things don't melt and all that sort of jazz. So, yeah, really interesting. And I hit message print. Oh, there we go. I can hear the print head going. It's printing something. I'd expect the ribbon to be worn out though. Whoa. Wow. I think it was doing all the dots there. No, I thought we had something. That's just those numbers are part of the paper there. So, yeah, our ribbon's gonski. I have no idea why that back plate was designed to come off if you just get mooned by the backplane PCB in there. Huh? Anyway, does that mean that all these are going to be just connected straight through to the backplane? Yeah, it looks like it. Got some surface mount something or other there. Okay, I was wondering how the heck this thing comes apart, and I think the chassis is supposed to slide out. No? Am I wrong? Am I wrong? My front panel's gonski. Okay, yeah, that was the screws in the top. Don't even know how you get in there to change the paper, actually. Okay, the back PCB assembly seems to be separate from this front mechanical print-in assembly, so there's some like little roller things down in there, which I don't, like almost as if it'll pull out, but nope, not seeing it. And unfortunately, there are two screws here, but they're not actually connected through to this main assembly down here, and I can't get them out. They're like stripped or something, which is really annoying. Okay, well that folds down like that. So, and our paper, okay, right, our paper is just, right, they're just folds, okay. Okay, I thought it was a roll of paper, but it's actually not. It's folded like that. There you go. It's interesting. Okay, like, can you buy that anymore? Like, would you even be able to buy that paper anymore? Oh, geez, it's their specific paper, NEC, sand, whatever. So this whole back assembly here, look, this all moves. I took all the screws out, but it's almost as if to get that out, you have to because this looks like this is welded. The back panel's welded to the chassis, so it's like you got to get the printing mechanism out first before you can get all the electronics out. Oh, damn it. And it does tantalizingly rock forward like that. Some progress by getting those two bolts out there, but still ain't budging. Aha, there's a third screw down in there. Geez, that's annoying. Well, that was the screw from hell. That was unbelievable. Will it come out now? Aha! There you go. Unbelievable. Well, partially. Oh, not quite. Come on. You can do it. Woohoo! Winner, winner. Chicken dinner, I think. Yep. Got it. Well, apart from that screw being hidden away like that very awkwardly, it's actually really nice. They've got some, really nice cable management, cable clamps and things, and, adequate length on the cables to just pull this out once you get, this ribbon out here and just swing the thing out. So, yeah, that's really groovy. So that's just all on its own. So we can just whip that out and get rid of the whole printer assembly. I mean, there's nothing in there. There's basically just your that's your roller motor there, which just goes through a couple of belts down here, and then just drives that. Then you got your stepper motor down in there, which drives your print head across. And yeah, that's pretty much all she wrote. And then the ribbon cable going to the print head. Big parallel jobby. None of that flat flex rubbish either. Proper ribbon cable. Awesome. Well, that is the most beautiful mechanical power switch I have ever seen in my life. Not so much the switch, but the way that they transfer. It's a little steel like belt in there, and I'm not sure if you can see it, but when I push on that, that physically zoom right into there, and just have a look down at these holes here. So to show you that, I'll just put a black marker on there like that. And we should be able to see that move. See? Look at that. Wow. And that can just snake its way anywhere within the product. That is absolutely brilliant. Wow. That is, seriously, has anyone ever seen a better physical remote power button solution than that. I have not. That is a first. That is absolutely fantastic. What would you call it? Does this even have a name? Let us know, please, in the comments down below if you've seen this in another product. It's like a physical belt kind of solution. Wow, love that. And it can just snake at any angle in your product. And there's that roller thing I was telling you about there, and I have no idea what that actually does. Mueller. So everything is connected in here except for, maybe I have to get this back plate off. Maybe it's actually terminated in there, because otherwise that's just soldered down to the power supply board down there. So there's the old school transformer. Look at that. There it is, multi-card solution. We can actually pull those out from here. We don't actually have to get that whole cage out, actually. But anyway, apart from like that transformer looks really old school. But that power supply down there looks relatively modern, I guess. This would be our data recorder. Obviously, these are all our input cards. We have relays on them, I can see. So this is all our memory recorder and printing and control processing stuff. So, yep, looks like I can get that whole assembly out. Look at that. That is amazing. Wonder whether that was the deliberate design choice to like build everything like into, like it has to go through the front. Everything's sort of pushed into the front like this. Whether that was a deliberate design choice from day one, or whether or not they just sort of fell into it somehow, or left over from a previous legacy design. But there you go. Wow. Check that out. That is the entire assembly. Wow. That's amazing. That's one mother of a PCB, isn't it? P8217, does that indicate the date? 1982? Seems a bit later than that, but anyway, let's see some IC numbers. And there's our main channel board. Look at that. There's like nothing on it. It's just relay switching and relay drivers. And if we have a look, a date code down in here, yep, sure enough, we got 1981 date code. So yeah, this is early 80s design and manufacture. NEC relays, of course, because it's an NEC company. And check out the fantastic slot going right through that board. Wow, no creepage at all. Well, you could actually get creepage from here. It could go down the edge of the PCB, across the bottom of the relay, up the other side, and then creep over to there. It's possible. Oops, that's actually 1991 manufacture. There you go, early 90s manufacture. And yeah, I can't, like, I'm looking through the tiny camcorder screen. All you people watching this in like 720p HD on your bloody big screens, yeah, it's easy to read. Anyway, yeah, 7887, like, that's probably not a date code, I would suspect. And there's one other board that's different, and this has our analog to digital converter. There's an AD652 there. I don't know that one offhand, but I'm sure that's an analog to digital converter. So the other cards actually have 7 relays. So, and we've got 5 of those cards. So like 35 channels, but I think we only have 30 on the back. And these may be doing some other switching. They're not actually channel inputs. So there you go. That looks fairly modern. Look at those chokes there with the SMD caps on top. That's very nice. Well, the filters, they're not just chokes, they're actually LF. LF stands for filter there, and just got some regulation, yeah, 7805 or something or other. And once again, date codes, we're putting this at, yeah, the early 90s for this. Early 90s design. So here you go. Wow, you know, there was still a market in the early to mid-90s, I guess, for like a 30-channel temperature logger to chart recorder thing. Okay, that wins the Capacitor of the Day award. Well, Capacitor Package of the Day award. Have you ever seen a cap like that? Anyone? Can't say I have. Oh, voltage reference, 10-volt voltage reference, LT 1031, 92, 5th week 92 manufacture. No, but I double checked. Turns out the AD652 is a synchronous frequency to voltage converter, which coincidentally is used for precision ADCs. And, you can see it's got its own localized ground over there. If we flip it over, you see we've got a nice little guard ring going around like that. That's just to prevent any leakage. And look, they've actually removed some of the solder mask around those pins there. So nice attention to detail, and the star grounding point over here. So they know what they're doing. And that LT1012 there, that's a very low offset, like down in the tens of microvolts range, picoamp input, super special op amp, and the capacitor package of the day there has something to do with that. It's almost as if it's like it's in there upside down or something, or it's, it's like there is another, this is just like a plastic package, and there's got to be a capacitor in there, right? And they're just potting it inside. Could I actually dig that out? Oh, I completely screwed the pooch on that one. I thought that C21, I thought that was a capacitor in 103. No, it's an inductor. Oops. Now let this be a lesson to all you young whippersnapper PCB layout designers out there. Look, they've got C22 right next to that one. Obvious. C24 right next to that one. Tons of room over here. Yet they're just gone flapping around in the breeze here. C23, why not put it like that? Come on, have some pride in your work. Like symmetrical, like C21 should be here, and this one's not labelled. Maybe it is underneath, but once again, that's poor PCB design layout. If it is, your designators should be outside. Should be, there. And it's processor board time. Oh, you big dip package fanboys are in for a treat. But first, let's have a look at this. Oh, wow. Look at the line of trannies there. That's unbelievable. Wow. All just flapping around in the breeze. None of that surface mount rubbish, of course. And, oh, wow. These are your print head drivers. There you go. 2, 4, 6, 8, 10, 12, 13. Print head drivers, I guess. Is it a 13-pin dot matrix? But, yep. That's what they're doing there. Anyway, this is the printer plotter PCB. It's upside down, so all the electrons are going to fall out, but we've got some NEC jobbies over here. 71055s. I don't know that offhand, but I'm assuming that there's some sort of like I/O expander because it's coming from the bus. We're going to get the processor on another board, and these are just I/O expanders for driving all of your dot matrix and your motor, stepper motor drivers and stuff like that. It's probably what these things over here are. That'd be stepper motor drivers from ST, and that's about all she wrote. Oh, and the 68,000 fanboys go wild. Wow, I didn't expect something as powerful as the 68,000 in a bit of kit like this, but there you have it. Oh, it's a monster, and none of that 2-layer rubbish. That's got to be at least 4 layers. Wow. Timer display PCB, and we've got surface mount. Check it out. But of course, that's what a typical driver would be for that LCD display. So they've just used Toshiba. They practically own the market for. Do they still do? I don't know. Anyway, backup battery over here. That's probably Gonski. But yeah, I'm not sure what that TMP82C79 is. Some sort of timer chip for the NiCad battery fanboys. An amp control data memory PCB. Once again, it looks like we've got one of these I/O expanders here, but where's the memory? Where's Wally? It's not populated. None of these are memory. These are just generic glue logic address decoders and whatnot. There's no memory. Oh, maybe that's like a $10,000 option or something. And the other optional cards, which we don't have, you can read down there, that's a remote control card slot. And up there is RS-232 and GPIB card slot. So you can access those connectors from the back, but you have to physically buy the boards and plug them into the cage here. And there's the power supply module, and there is the other end of the physical, that, band interface switch, for want of a better word. And anyway, beautiful. And we've got terminated. Yep, we've got extra windings there. Terminated. Beautiful old school transformer. Oh, look at that. For all you transformer fanboys. Oh. Anyway, the power supply down there, that looks very nice. They didn't farm that out. They designed that themselves. Thank you very much. And, ooh, SGS. Wow. Check out that. Wow, I can't get a part number from here, but gee. And Nippon Chemicon, of course, 35-volt jobbies. And that looks like it would be super reliable, and of course it is, because it's still working, like 30 years later. So there you have it. I hope you enjoyed that mystery dumpster teardown. That was like absolutely fascinating. We've seen like a switch mechanism that we've never seen before, and it's not like the first time we've seen a design where like everything like goes from the top, but it's pretty rare. I can recall it a couple of times. Can't remember exactly what products, but I have seen it before where everything sort of gets shoved in the front, and this one's done in multiple layers. So you know, like the power supply can go in on its own, it just slides in. I just got out of, you know, one screw in there, held in that, and screws on the back. And then we've got this gorgeous cage which holds all the processors and all the input stuff as well, and it's all just one big assembly, which of course is fantastic because then you can assemble that in its own on its own line. You know, as part of the assembly line, you'd have a bench dedicated to assembling and testing all these assemblies. You'd have another one dedicated to assembling and testing the entire printer cage. So that all just came out nicely. And it's just nice to see like different variations in designs like this. And as I said, like this is still used in at least like early to mid 90s, and well, it was still used up until, you know, like 5 years ago when it was last calibrated. So a real specialised bit of kit where you absolutely need, due to some red tape requirement perhaps, or as I said, you know, you just want that physical output so it doesn't matter what else happens, you've at least got it on the paper. But this is actually storing it in memory and then it dumps it. Maybe it does have like a real-time plotting mode or something like that perhaps, but of course it's going to be a bit slow. There'd have to be some sort of buffer there, some sort of, you know, digital memory buffer, because it's a dot matrix printer. It's not like you have like 30 different pens all going wiggle, 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 yeah, you know, like multi-channel like you see in the movies with those seismic, you know, data recorders that just print onto gigantic, you know, hundreds of meter long rolls of paper. This one is, no, it's just designed to sort of like store it in memory, and a dot matrix printer just you know, prints it out. So it couldn't do that in real time. You couldn't get all the channels going wiggle, wiggle, wiggle and doing that, because it takes time for that print head to scan across and do the raster rows like that. So it's got to have the digital memory. So I guess that's why they call it like a hybrid recorder. Really interesting. So please leave it in the comments down below if you've ever used one of these things. What for? As I said, I gave an example. You know, you might have, obviously designed for massive temperature ranges for some sort of, you know, testing application, something like that, like a jet engine or something like that. And it wouldn't be uncommon for designs like that. Even stuff that I've worked on, I've put in like a dozen thermocouples into, well, little temperature logger buttons, those old Dallas buttons, you know, they were great. Little independent temperature loggers. You whack those into different parts of a product and things like that, just to measure the different temperatures at different, you know, parts of your product, and you can get thermal profiles and stuff like that. But you might have a, you know, a jet engine or a car motor or something that you're working on, and you want to measure, you know, dozens of different temperature channels. You might want something like this, but you know, it's all digital these days. But yeah, all this could be reduced to, you know, a tiny little box, you know, 30-channel box like this big or something, and it'll all store it all digitally and hook up to USB, and it'll have gigabytes of internal memory saved into SD card or whatever in real time, and then you can just dump it all later for analysis. But this is how it was done in the 80s, which is, I believe this would have been designed in the 80s and manufactured, would have came from earlier products, would have been an evolution of products. So if you've got any detail on the company, if you've got a link to a user manual, I couldn't find one, yeah, please leave it in the comments down below. But I hope you found it as interesting as I did. If you did, please give it a big thumbs up. And as always, you can follow me on all my alternate channels, alt tech channels. I'm on everything. I've got a new one coming on, Utreon, soon. My videos are transferring over as we speak. Anyway, catch you next time.